I'm John Davis, and today we're in the field in Roby, Texas. In 2010, the plentiful rains brought the rolling plains of Texas to life. Quail were everywhere. It seemed like it was going to be a great year for hunting that October. Then suddenly, quail disappeared, and no one knew why. That's when Texas Tech got involved to find out exactly what was going on with these mysterious disappearing quail. I'm here today with Dr. Ron Kendall, professor in the Department of Wildlife Toxicology at Texas Tech.
Hello, John.
Hi, Ron. Thanks for joining us today.
You bet.
So tell me a little bit, what happened to make all the quail disappear?
Well, looking back to 2010, we had excellent bird numbers going into the spring. It was green. There was plenty of rain, good habitat. By September, the quail had pretty much disappeared in the rolling plains. The issue that came to the surface over these years has been the role of parasites, and particularly a worm that's a nematode called an eyeworm that exists in the eye and behind the eye of wild quail. And we have a scientific team that can receive samples of wild quail and be able to look at those samples without harming the bird, without killing the bird, and determine if those birds are infected with particularly the parasite, the eyeworm.
Excellent. Well, let's see what we can get into today.
Hey, John, I want you to meet my friend here. This is Dr. Dale Rollins.
Nice to meet you.
This is John Davis from Texas Tech University, and this is Dr. Dale Rollins. He's the executive director of the Rolling Plains Quail Research Ranch and our partner with the Mobile Research Laboratory.
Excellent.
Dale, we're glad to be here.
Well, thank you for having us, for sure. Tell me a little bit about this ranch and what you guys do here.
Well, this is the one-of-a-kind laboratory. It's a 4,720-acre ranch that was donated strictly for the conservation of the bobwhite in West Texas. So we say that here at the Research Ranch, everything points to quail.
Tell me a little bit about what we're doing today and how we're going to help quail live.
Well, we're down here to work with Dr. Kendall and his mobile parasite lab, so we're going to be trying to trap some quail and bring those live specimens in and do some in vivo live testing of those birds to where we're not killing. We're just going to be sampling them, seeing if about the presence of the eyeworm. And this is all laying the track, laying the groundwork then for what we're going to be doing later on this fall when we have hunters and so forth bring in quail to have their quail checked for the presence of eyeworms and for the intensity of eyeworms, and then that'll dictate whether or not we want to evaluate this medicated feed on some of their property.
I see. All right. Well, I guess we'll go check some traps.
Check some traps.
All right.
Well, it looks like we do have some kind of bird in here.
Oh, we sure do.
Well, lo and behold, it's not a bobwhite. It's a blue quail.
Is it?
Yeah. I'll tell you what, John, I'm going to ask that you take that bird out of that trap for me, okay? So it'll be a little hands-on.
Okay. What do you want?
Just get right over here.
Okay.
Hold him like this right here. Hold him like that right there. And that way you got you got a secure but a safe grip on him right there. Again, that's a blue quail, which we are very proud of down here at the Rolling Plains Quail Research Ranch because we started translocating them about 2 years ago, and they've done very well, so we're very proud to see them. So go ahead and just drop that one in the pillowcase here.
Okay, there you go.
And we'll take it back to the mobile lab and check it for eyeworm DNA.
Okay, sounds good.
If we go one more trap to check, maybe we'll catch a bobwhite down there.
Let's give it a try.
All right, John, now we caught these birds, we're going to bring them in and test them with this new lab so we can look at the DNA of these quail.
Okay.
And we do that by taking a swab of their cloacal region, their rear end.
Oh.
We're going to let Dr. Julie Parlos, who's a senior research associate with the Wildlife Toxicology Lab at Texas Tech University.
Hi.
Hello.
How are you?
We've been very fortunate to have the assistance of Dr. Kendall's lab up at Texas Tech to develop a lot of this, and so
okay.
What we're going to do is we have a nice healthy rooster that was trapped this morning, and Julie, if you will,
So I'm going to take the cloacal swab. So
Okay.
this is a sterile swab.
What exactly is a cloacal swab?
So where the bird lays its eggs or defecates from is the cloaca. And this swab will go inside the cloaca and it will grab any fecal material that's in there, and the parasite's eggs are going to be in the fecal material. So if the bird has any parasites, we'll be able to pick up the eggs on this swab when we take it into the lab to test for the DNA.
Oh, okay. Well, I'll leave that to the expert.
There we go. Okay.
All right.
Sometimes they come out a little dirtier than others, but this one isn't too dirty.
Okay. So the more DNA that turns up in these samples, the more infected one of these birds are.
It'll basically give us an opportunity to inventory what our parasite load is, just like you'd take your dog into the vet to have a stool sample done if you were concerned about heartworms or tapeworms.
Here in the lab, and as you can see, we came from a farmhouse site to a molecular biology lab just with one step.
Yeah.
And here it's clean. We're doing DNA work tied to parasite infection, and I'll let our scientist discuss this with you.
All right. So Julie, what's happening?
Okay, so the first thing I'm going to go ahead and do is I've prepared my tubes.
Okay.
And I'm going to take the cloacal swab that we just took from the bird, and I will break it inside of each one of these tubes. And I've put these little metal beads in here. So the parasite's eggs are kind of tough, so we add these metal beads in to break open those eggs so that we can release the DNA.
Oh, okay.
And using our method with the beads and with the liquid nitrogen combined, the liquid nitrogen will reduce the integrity of the parasite's egg. We can break it open. We've had success with 10 out of 10 eggs getting broken open. So very, very good chance that if we have a single egg in this tube, we will break it open and get the DNA and be able to find out if the parasite is living in that bird. Pull this off, and you can see the cold coming off of it. And we just dip it in, and all it takes is really a second just to flash freeze it. So now I'm going to add the first reagent in our DNA extraction. So the next thing that I do is going to be pretty loud. I'm going to put the samples into this bead beater. It's called a Genie Disruptor.
So after 5 minutes in the bead, disruptor genie, what happens then?
Then we go ahead and incubate the samples. We're going to be adding this tablet called the Inhibitex tablet, and this will be another step in removing any of the inhibitors out of the PCR to make sure that our PCR works appropriately and that we don't get any false negatives. So I'm going to set my timer for 10 minutes and we'll get these samples into the heat block and let them incubate for 10 minutes. So I'm going to transfer some of our sample now into the tube with the Inhibitex tablet so that we can continue removing some of those inhibitors that we find in fecal material. Another spin down. And so the next few steps are going to be washing it and just trying to get the other impurities out. And so we just end up with the DNA, and then we'll move to the PCR reaction.
Okay, good deal. What's the prognosis, doctor?
Well, for the bird that we swabbed here, he actually came back negative. We don't see any evidence that he's infected at this time.
Oh, that's good. That's good.
Yeah, but we can tell if we look at some of the other birds that we swabbed. You see, we have this kind of straight line right here, but we have this line that shoots up like that, or this bird with this line that shoots up. So out of the 5 DNAs that we tested today, 2 of them did come back positive.
I see. So that means that the parasite is present in the wild community, and what happens now? You guys just keep an eye on it to see how it
We'll see how it keeps on progressing. I mean, we do know that it is present here in West Texas, and so part of what we're trying to do is establish how high the infection levels are. And we do know that if these birds have a lot of parasites behind their eye, it is causing damage, and that could lead to the birds dying in many different ways, such as getting preyed upon, not being able to escape their natural predators as easily.
So, what did we learn today? Well, in 2010 there was a massive quail die-off, and nobody really knew why. But now Texas Tech researchers and others are trying to find out why, what the causes are, and how we can prevent a future die-off like what we saw before. For John Davis, I'm in the field.
On behalf of the Wildlife Toxicology Laboratory at Texas Tech University, we would like to say thank you to Park Cities Quail and the Rolling Plains Quail Research Foundation for supporting the extensive research that we've done related to the infection of wild quail with parasites, as well as the development of this mobile research laboratory to evaluate these infections. Thank you for your support.
Hey there. Me and the girls are about to go find us some quail out in the field. But before we do that, make sure you click the subscribe button. We'll see you in the field.